These things take a while. So go ahead and graph day 6, number 1 for me, and then we'll talk. Before I even get into the proof, I have mentioned a few times already, the entire test is done in pen, including your bubble sheet, except for 2 things. And what are those 2 things? Graphs and what else can be done in pencil?
Instructions.
No, multiple choice has to, well, the work in your booklet, but the bubble sheet needs to be done in pen. Amy? Constructions, right? Constructions and graphs. Now, here's what I mean by the word graph. Is literally this can be done in pencil, but the work we're about to do around it has to be done in pen. All right, so the only thing in pencil is the graph. Any work around it has to be done in pen.
If the work's in pencil, does it just not count?
I don't know what we would do. I've heard some years we'd have to call a student and bring them back in so they can go over it in pen. But I think it's a foolish rule, to be honest. The reason it's there, I think, is to do everything in pen is so I personally cannot go back and like change it and erase it if it's in pencil and put the right work. Not that I would put my job or my life on the line for any of you, even though you guys are great kids, but that would never happen. But I think that's the reasoning why. Everything's got to be done in pen. All right, so everyone good? Graph and pencil, everything around it in pen. Before we even start this proof, look at the second given other than the coordinates. We got midpoints. D, E, and F are all midpoints. So why don't we take that formulas you have to know and look at number 2. And let's write down what the midpoint formula is because we need it right now in this proof. So midpoint is equal to, anybody remember it? I'm not going to wait anyway. Add your x's, divide by 2, and add your y's, divide by 2. So take a minute or 2 right now and please find point D, E, and F and graph it. Make sure you graph them as well so we can actually go on to the proof statement. All right, here we go. Everyone's got -2, 3, 4, 3, 0, -2. We're ready to move on with the proof. First part says prove, follow the letters. A, D, E, F is a parallelogram. So if you want to draw that in, A, D, E, F, we need to show this quadrilateral is a parallelogram. And this is called a coordinate proof. It's not statements reasons. This is a coordinate proof. But as you guys know, the one person who's not allowed to grade your regents, and that's me. Keep everything organized and neat for whoever is going to grade it, though. I still want, even though this is not statements reasons, I still want the steps. So whoever is grading it knows, all right, steps 1, 2, 3, 4, we follow it in a nice, neat, organized manner. If you're going to prove it a parallelogram, there are 4 different ways we could do this. So let's go over all 4 ways. I'm going to pick one of you guys to choose a way. First way would be to show both pair of opposite sides are parallel, right? That's a property. What formula would I need to do that? Slope formula. All right, so maybe you're a slope person and you want to do it that way. Maybe you're not a slope person. Maybe you want to do it opposite sides are congruent. Instead, what would I need there? Distance. Maybe you just want to show off, and that's all you're doing is showing off. We had what was called a special case, which was the same pair of opposite sides are both congruent and parallel. So that would be slope and distance. And I'll show you this one here just to keep in the back of your mind. I don't know if it'll ever come up. What do you know about the diagonals of a parallelogram? They bisect each other. How would you show that? Well, take a look. That would be true, right? And that would be true if they bisect each other, meaning, what's this bad boy right here where they meet? That's the midpoint of each diagonal. So show they share the same midpoint. That's the other way to show a parallelogram. All right, so 4 options. Somebody's going to decide for our class here which way you want to do. But remember, on Regents Day, you can do whatever you're comfortable with. I just want to make sure we're consistent today and do it all the same way. Oh, Olivia, big decision here. Big decision. What way do you want to do? You want to do parallel? Okay, let's do parallel then. That means I'm going to need, you guys told me what formula? Slope. It's number 3 on your formulas to know if you want to fill it in. And I'll let you know, Olivia, you were the first person to do that today out of my 4 classes. Everyone picked congruent. So
The sides are congruent?
yes, everyone picked opposite sides congruent. No, actually, it's not, and I'll tell you, I'll tell you why here as we move on. But I want to do it, Olivia. Don't worry about it. All right, stop arguing. Stop arguing. Slope. There's 2 versions I'll give you. Change in y, y2 minus y1 over x2 minus x1. I don't prefer that one, especially when something's graph for me because I can count. I've been doing it all my life, and that's why I like to do rise over run instead. So your choice right now, your choice. So we're going to have to show the slopes of all 4 sides, and hopefully 2 of them will be equal and another 2 will be equal. Before you do that, though, let's make your life easy. You're going to do the slope of AD, and then you'll do the slope of FE using rise over run or change in Y over change in X. Real quick, I don't need to do that for AF and DE, though. Anybody see why? You could. I don't know how you're going to do rise over run, though, but you could plug them into change in Y over change in X, but can we just discuss this real quick? DE and AF, anybody know their slopes? Yeah, horizontal lines. They're horizontal, so they automatically have a slope of 0. I don't need to show any work. Vertical, what about vertical while we're on the topic? No slope, undefined. Not 0, no slope, undefined. So go ahead, find the slope of AD and FE. And remember, this is not a true, false, yes, no question. The darn slope should come out to be equal. You're proving it a parallelogram. It's not like, nope, sorry, and it really wasn't a parallelogram. Oh, really? That's interesting. What are you guys looking at? 5/4? How's 5/4 look? Positive 5/4, right? Anybody need anything you want to ask getting those slopes? 5 over 4. All right, step 2 in every coordinate proof, from us anyway, from my students, is to tell whoever's grading it, what did you just show in step 1? And the answer is not you showed it a parallelogram. You haven't shown that yet. What did you just show by doing the slope formulas in step 1. What did we show here? Who, in your own words, Amy, what did we show?
Opposite sides parallel.
Okay, but I want to write that out, right? I don't want to put those words. I want to say AD is parallel to FE and DE parallel to AF. Because, and you always have to have a because here. How do we know those two in particular are parallel to each other? What work do you already do there? Haley?
Those slopes are the same.
That's all I need. Slopes are equal. Now, for some of you, this could have been a totally different proof if you decide to do distance formula. Now you tell me the sides are equal because distances are equal. Okay? So it could have been a different proof if you decided on the congruent instead. All right, now we can say it's a parallelogram, right? ADEF is a parallelogram. Remember, I definitely mentioned to you guys, you can use my shorthand, parallelogram. There's one you can use. ACEF is a parallelogram because, what's your good reason here? What did we just show again? Charlie?
Opposite sides parallel.
Done. Opposite sides parallel. There's the first part of the proof done. Any questions? All right, ready for the second part? Prove it's not a rhombus. What's the big property of a rhombus?
All sides.
All sides equal. All right, now, this is why maybe doing distance formula would have helped you at the beginning because we wouldn't have to do it. We could just see by doing them already that they're not equal. Two of them aren't equal, but hey, it is what it is. It's what Olivia chose, and I'm fine with it. So now we got to do the distance of two sides and show they're not equal. But it's not even that bad. I say the distance of two sides. Pick two sides you want to find. Pick two. Just let's start there. Pick two sides here. Where am I going with that one? Doyle, pick two sides you want to find the distance of. AF and AD. Perfect. I'm not using the distance formula on AF. I don't need to. Why not? Why don't I need the distance formula on AF to find its length? I hope you're darn right. That's why you're in honors, right? Because all of you passed the counting test. All right, way back in the day. That's why you're in honors. What were those sides again, Doyle? AF and ED? AD, thank you. There is no ED. There you go. So AF, there you go. So what is it, 6? 1, 2, 3, 4, 5, 6. Yep, I passed my counting test too. So AF is 6. AD, ready? I guess we should put this in number 1 now, right? Distance formula. I should have wrote it first. Distance formula. And again, the formula itself does not have to show up on the proof. I'm just putting it in here because you guys got to write it down. It does not have to show up in your proof. Just plug in your numbers and go. X2 minus X1 all squared plus Y2 minus Y1 all squared. Look at that. We went over all 3 formulas today. Go ahead and now I know some of you have been chirping up. I like to use Pythag. All right, go ahead. Use Pythagorean theorem. Okay, that's fine. No issues there. Go ahead, plug in your numbers, and let's find the distance of AD. Hopefully it's not 6, right? Square root of 41. You got 4 and negative 4 in one of the parentheses and 5 and negative 5 in the other. Looks good. All right, you guys know the deal. Every time you do a formula, next step should be what did you just learn? Now we just learned, I'll just finish this up quick. AF, you can put not equal to, not congruent to. AD, because distances are not equal, distances are different. So it's that. There's the format. Give me a formula, tell me what you learned, and then in the final step, all right, I don't think this is a rhombus. What is it? A, B, A, D, E, F is not a rhombus because, and then I'll leave that up to somebody in this class. What's a good reason why it's not a rhombus? It's not a rhombus because, one more try. Z, why isn't this bad boy a rhombus?
All sides are equal.
Fine. Notice what you're looking at right now, hopefully, is neat and organized, isn't it? So whatever teacher picks up your exam and corrects that problem, they're looking forward to this because it's not all over the place. Questions? Before you graph the next one, just a heads up with point K. Before you make your XY axes, point K has an X coordinate of 13, so be careful there, please. All right. Just give you a heads up, so you don't have to do what I did, which is make your traditional right down the middle XY axes and then figure out I don't have 13 spots. And there is no shot anybody in any one of my students anyway in an honors level class is going to be extending it and doing that bad. And that's not enough. Get out of here. Get out of here. That's embarrassing. I would not claim you as my student if you did that.
Oh, I did that last year.
All right, all graphed. Two-part proof again. First part, prove it's a trapezoid. There's only one property, and that's the only thing you have to prove. There's only one property of a trapezoid, and that is one pair of opposite sides needs to be parallel, and it's a trapezoid. One pair of opposite sides needs to be parallel. So if you look at the graph, I'm sure we can guess it's going to be L, M, and KJ, right? We're going to try to prove parallel. So we know we need the slope formula. So I'll give you guys a second and find the slopes of M, L, and find the slope of KJ. They did come out to be different numbers, but hopefully they reduced to the same amount, correct? 6/12 and 4/8. Do a little reducing there, 1/2 each. Positive 1/2 for their slopes. Perfect. Just like we did in the last one, step 2, what did we just learn, right? What did we just learn doing that? Step 2, what did we just learn? Oh, Steve, what did we just learn?
The slope of
Are you okay?
the wrong.
We need to do a wellness check on you. You all right?
I did put the wrong.
What did we just learn here? What did I-
And two lines up. ML and KJ are of the slopes that are
so that makes them?
parallel.
Thank you. Thank you. We got it. ML parallel to KJ, and Ziva already did it because slopes are equal. Good. That's all I need. Now that quadrilateral becomes a trapezoid. MLKJ is a trapezoid. Be careful of your because here. I'm a little nervous. Don't make this plural. It's not because opposite sides are parallel. That's not what you proved. That's not what you proved. It's because you proved one pair. One pair of opposite sides parallel. Don't make it into both pair or pairs. Not bad. That's pretty easy to prove a trapezoid. All right, a little bit tougher now is the second part. It is a trapezoid, but why is it not isosceles? Let's back up a little bit. What would make it isosceles? This is a trapezoid right now. What would I need to do to make the trapezoid into isosceles so I can prove it's not happening? Congruent. Wow, that's absolutely correct, and that I did not expect that. You threw me off there. Yes, you could prove the diagonals are not congruent by doing the distance. Props. That hair, I'm telling you, like it's just more room to think about things. I'm telling you. And now you're laying off the hand sanitizer nowadays, taking a break. You're into it more, Josh. I love it. Yes, I could prove the diagonals are not congruent, or I wasn't even thinking that, or prove the other pair of sides are not congruent. Anybody remember what we call those in the isosceles trapezoid? It's called the legs. Yeah, that's absolutely right. Wow. All right, bring that in a couple weeks. Prove the legs not congruent. So that's what I'm going to do right here. Distance formula to show MJ and LK do not have the same distances. So I will let you go there. MJ, LK, we've already talked about what the distance formula is, so do your thing, or Pythag. Or again, and I don't want to, I'm not making fun of it. What Josh said, if you want to prove the diagonals are congruent, that is a method, because that is a property of an isosceles trapezoid. How's 3 radical 5 and radical 65 look? Keep going if you're calculating. 3 radical 5, or if you had radical 45, that's fine, and radical 65. And then you guys know, next step, show me what we just learned right there. We just found out that MJ is not equal to LK. Because distances are not equal. And then now it's not an isosceles trapezoid. because Josh just gave you guys the official term, the legs, but you don't need to write that. It's not required that I see the word legs. You could say the other pair of sides are not congruent. The non-parallel sides are not, whatever gets the point across that you're talking about the other two sides. All right, so I'm going to keep with legs though, because legs are not congruent. All right, you don't have to use that vocabulary term. Just get the point across.